Okay, good morning, my dear students, grade 10 students on our session today. Today, inshallah, we'll complete yesterday lesson or before yesterday. I think yesterday was we don't have a session. Okay,
Good
so
morning, Mr. Moon.
good morning. So, inshallah, we will work
Morning.
together to get some information and also revise on what we said before. First, I need to solve this example. This example, it's related to algebra or in the figure opposite or in the figure circle G is congruent to circle H and the measure of arc RT is equal to measure of arc LM or RT arc is congruent to LM arc. Find the LM, find the length of LM. If you don't write the line, it means I need to find the length of LM. I need to find this. I need to find this LM. So this line, which represent a chord. So I need to find this chord. I need to find this chord. Okay. Before we start, inshallah, our exam will be, I think, after 2 weeks from now. So please try to do your best. Try to do your best. Okay. We have sheets, we have electronic homeworks, we have live classes. So please, this is your material. This is your material. Okay. And this is also your attendance participation. Okay, I start with Mazen. Okay, Mazen.
Yes, Mr.
Okay.
Uh, the RT and LM are equal because the arc RT and the arc LM are equal.
So according to yes, the theorem, we have we said that if the measure of the arc RT and the measure of the arc LM in two congruent circles are equal, so the measure of the two corresponding chords are equal. Okay, this is the first
Yes.
step. Yes, after that.
We are going to write that 3x minus 5 equal 2x plus 1.
So as we know that RT will be equal to LM. I need to find LM. So RT equal to 3x minus 5 as he write. So 3x minus 5 is equal to
2x plus 1.
2x plus 1. After that,
We are going to minus 2x minus 2x.
so I have two variables or variable in each side. So I need to remove one of them. So minus 2x, I choose the smallest one. Okay, and from here minus 2x and then cancel. So cancel here and cancel in the other side. 3x minus 2x equal
X equal x
x
minus 5
minus 5
plus equal 1.
equal 1. Thanks,
2
Mazen.
plus
I
5.
need, thanks.
Okay.
Thanks, Mazen. I need Abdullah El-Anazi to complete. Abdullah.
Yes, Mr.
Okay, complete. I need to find the value of x. X minus 5
Wait.
equal 1.
You need to find the value of x.
Yes.
We do plus 5. Plus 5.
Excellent. We do plus 5 in both sides or add 5 to both sides. So plus 5 here and plus
X.
5 here.
Yes.
So as you said, x equal
X equals 6.
x equal to 6. The problem here don't end yet because we don't find the value of LM. Pay attention with me, Abdullah. LM is equal what?
LM
is equal to
2x plus 1.
yes, and the value of x, we get the value of x
Yes, 6.
6. So if we need to get LM, so LM equal 2x plus 1,
X plus 1.
substitute 2x, it means 2 times 6. 2 times 6 equal
2 times 6, 12.
12 plus 1
Yes,
equal
13.
to 13, which is letter,
Letter D.
which is letter D. So the answer will be letter D, as Abdullah and Mazen said. We have here, we start the problem by the previous theorem. The theorem said that if we have two congruent circles or two same or a same in a same circle, if we have the measure of two arcs are equal to the corresponding chords are also equal or congruent. Mazen used this theorem and substitute. Abdullah complete substitution till we find the value of x. The problem here, we don't find the LM. We need to find the LM, so we substitute by the value of x for the equation of LM, which is 2x plus 1. We get the value, which is 30. Okay, we have here the answer of this example. Then we will go to a new theorem. A new theorem. Theorem
خلاص
9.
مستر. I mute my
What?
I mute myself or خلاص.
Okay, okay, there is no problem. Okay, okay, Abdullah. Thanks, Abdullah. Thanks, Mazen. I'm going to theorem 9.3. In theorem 9.3, if a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Again, from the beginning, I read it again. If a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and its arcs. On the drawing, we have a diameter, which is AB, or maybe the circle, the radius, which is CB. If this diameter or this radius, perpendicular, it means this angle is 90 degrees, perpendicular to a chord. This chord is XY. This chord is XY. So if AB or CB is perpendicular to XY, that represent a chord, then what's happened? The length of XZ equal the length of YZ. It means if XY equal 10 centimeter, for example, so XZ is 5 and YZ is 5. Bisect, it means it's divided into two equal parts. It's divided into two equal parts. The word bisect, it means this radius or diameter divides the chord into two equal parts. Okay, and also divides the arc. It means the arc XB equal to the arc YB. The arc XB equal to the arc YB. It means if this arc is 75 degree, this arc also will be 75 degree. Or if he gave me the whole measure of the arc XY, for example, 100, so the small arc here will be 50 degree and the small arc here will be 50 degree. This is the theorem. Again, the theorem said that if we have a diameter or a radius, this diameter or radius, which represented on the drawing by AB, okay, is perpendicular. It means this angle is 90 to a chord, which is XY in the drawing. So we have to get two equal lines and two equals measure. The two equal lines are XZ and YZ. It means the chord is bisected into two equal parts or divided into two equal parts. The word bisect, it means divide. Okay. After that, also this arc, which is called the XBY, XBY is divided into two parts. This is the first part, and this is the second part. So these two parts also are equal. Okay, this is theorem 9.3. This is theorem 9.3. I'm going to Faisal. Faisal, can you read the theorem 9.3, please? Faisal.
Yes, mister.
Okay, read the theorem 9.3.
If diameter or radius مدري ايش دي of a circle
radius
is
of a
a
circle, yes,
molecule
is perpendicular. Perpendicular, it means this angle is 90, as you see here. As you see here, this angle is 90. Yes. To a chord, what's happened?
a chord and in the short and its arc.
Yes, then it's bisect the chord and its arc. Okay, thanks, Faisal. We're going to 9.4 or another theorem. If we have, it's the opposite. It's the opposite. Okay, I said that if I have a diameter and this diameter is perpendicular to the chord, so it bisects the chord and its opposite arc. This is the first one. I'm going to the second one. It's the opposite. If we have an perpendicular bisector, it means this line, which is AB, is perpendicular to XY. It means this angle is 90, and also bisect XY. It means this part is equal to this part. Okay, so this line will be a diameter. So this line will be a diameter. Okay, again, in the first example, he gave me a diameter as information. We have a diameter and this diameter is perpendicular. So it's bisect. But in 9.4, if we have a perpendicular bisector, it means a line bisect, it means divide into two equal parts, and perpendicular to a chord, so it will be a diameter. It will be a diameter. So we have three informations. He gave me two and asked me about the third. Pay attention with me. Three informations. What are the three information? Perpendicular, bisect, diameter. If he gave me diameter and perpendicular, so it's bisect. If he gave me perpendicular bisector, so it's diameter. Okay, I think it's very easy now. Okay, let's go about the examples. Okay, these examples, the first example, in circle G, measure of the arc DEF equal 150. Find measure of DE. Again, if I have a circle G, this circle, the measure of the arc DEF, it means all this arc, okay, equal 150, equal 150 degree. I need to find the measure of the small arc DE. So DE equals to what? Okay, okay. I'm going to Hamoud. Hamoud. Please, Hamoud, don't close the mic. Yes. Okay.
By mistake.
Okay, Hamoud. In the circle G, we have measure of the arc DEF equal 150. Find measure of the arc DE.
75.
How you get it? 75 is right. How you get it?
Because if you the whole measure is
150.
150.
So, and this line, which is called GE. So the line GE is a radius.
It's the radius.
This is number one.
Yes.
And the perpendicular to the chord. And the
And
perpendicular to the chord. I
150,
said
150 divided by 2 is 75.
yes. So we deduce that this is a radius and we have a chord. This radius is perpendicular to the chord, so it's bisect the chord and also bisect the arc. The arc is 150. If we divide it by 2 equals 75. Thanks, Hamoud. This is the answer. I just write the answers by steps. We have here the radius EG is perpendicular to the chord DF. So by theorem 10 3, it's 9 3 about the number of the chapter, no problem. EG bisects the chord, sorry, the arc DEF. Therefore, measure of the arc DE equal measure of the arc EF. By substitution, 150 over 2 equals 75 as Hamoud said. So this is the answer of example 3. This is the answer of example 3. Okay. Okay, if you need to draw it quickly and write the answer, there is no problem. Okay. I'm going to the next example. Okay. So 75. We have here a choose or multiple choice. This one of the problems that you may find in your exam, because the whole exam will be multiple choice. So we have here, I'm going to Ziad. Okay, Ziad.
Yes, mister.
Okay. Can you read the
So,
example, please?
the question said the circle Z MWUX equals to 160.
Measure of arc, measure
Measure
of arc WX.
measure of arc WUX is equal 160.
Yes.
Find measure of arc UX.
Yes.
So 160 divided by 2, which equals 80. This is the answer of
This
measure
is the
arc
answer.
UX.
Excellent. So the measure of the arc UX is half the total arc. So it's equal to 80, which is letter B. If you need to draw the circle quickly and draw the problem, no problem about it. Okay, quickly. You have about 30 seconds. Okay. We're going to
Mute myself, Mr. Right?
okay.
Thank you.
Okay, we're going to another example. Okay. Okay. This example is a little bit hard example, but we will talk together, inshallah, and we will simplify it. We're going to Muhammad Rafa.
ناديني ذا
Muhammad Rafa.
hello
Muhammad.
yes
Okay, can you read the example, please? Muhammad Rafa. Okay. Okay, Muhammad.
yes
Okay, can you read the example?
and the ceramic stepping stone below diameter line AB is 18 inches long
Yes.
and chord line EF is 8 inches long.
Yes.
Find CD.
So we have, as you see,
Yes.
you have a tile or a ceramic tile. We have the diameter is AB and its long is or its length is 18 inches, and the chord is EF and EF is 8 inches long. Find CD. So we will start by drawing the problem as you see. As you see, this is the ceramic tile, okay, or the ceramic stone, and we have AB is the diameter and its long is 18 as he said. So this is 18, or the whole diameter is 18. Okay.
Yes.
And he said also that EF is equal to
AF is equal to 8 inches.
Is equal to 8 inches. So this is we have this is 8. So the whole length here is 8. Okay, I need to find CE. I need to find sorry, I need to find first. I can go to the problem again. Sorry, to find what the requirement.
I think it was
I need to find, I'm going to the requirement again. I need to find CD. I need to find CD. Okay, return to the problem again. I need to find CD. So I need to find this part. Okay, CD. So I have here to shaded by the red pen. I need to find this part. Okay, the length of this line. What shall we do, Muhammad?
yes, the length of this line.
What shall we do to find it?
First, we know that the length from C to B is 9 inches.
Yes.
And we know that EF is 8 inches. So I think, wait 1 second.
Muhammad, can I ask you about
yes.
CE? CE equals what?
C is a radius.
So it's equal to?
9 inches.
Excellent. So CE is a radius and the diameter is 18. So CE equal to 9. It's a half
yes.
The length of the diameter. Okay.
And this is 4. ED is 4.
Excellent. From what you get this side is 4.
Because it's half from EF.
Excellent. Because as we said in theorem 9.3, if we have a diameter and this diameter is perpendicular to a chord, so it's bisected length. So this is 8, this is becomes 4. Now you have a right angle triangle. A right angle triangle, Muhammad. You have two sides.
Yes.
Can you get the third side, which is CD?
Yes, 1 second. We do 9
Yes.
all under root
Excellent. So we have a square root and you use Pythagorean theorem. Yes?
Yes.
Complete?
Yes. We use Pythagorean theorem, so it's 9 power 2
Excellent.
minus 4 power 2.
Excellent, Muhammad. Minus, because 9 is the hypotenuse for the triangle. So we make minus, not plus, minus 4 power 2. And we get the result. And we get the result. It's what?
It's 8.1.
Excellent. It's approximately 8.1. Excellent, Muhammad. Excellent, Muhammad. I give you the steps by a clear handwriting, or here if we have. So this forms a right angle triangle CDE as we work in the right angle triangle. And then after that, CE and DE, we have here 18 inches. So CB equal 9, as Muhammad said, it's a radius because all radii in the same circle are congruent. So CE equal 9 inches. And also, as we have the theorem said, the chord is bisected, so it's equal 4 inches. Now we use the Pythagorean theorem to get CD, as Muhammad said. So by using Pythagorean theorem, we get it's a square root of 65 or about 8.1 if you approximate to the nearest one decimal place.
Okay.
Thanks, Muhammad. Okay, so we need to complete another theorem. Okay, we're going to okay. Another theorem, 9.5. 9.5. I read it. Okay, in the same circle or congruent circles, two chords are congruent if and only if. So if you have two congruent circles, or in a same circle, two chords are congruent if. It means this chord, which FG or HG, are congruent. It means they are equal. If and only if. Okay? Under a special condition. What is the special condition? They are equidistant from the center. They are equidistant from the center. Pay attention about this word. Equidistant from the center. What's meant by equidistant from the center? It means the length of LX equal the length of LY. It means the distance from the center to the first chord is equal to the distance from the center and the second chord. So these two chords that I'll shade them or write on them by the black pen, which is FG and JH, are equal if and only if the distance here equal the distance here. It means, for example, this is 3 and this is 3. If they are equal distance, it means the word equal distance, so they are congruent. So they are congruent. Okay, I'm going to Salman Fahd. Please, Salman, can you read the theorem again?
What the words
Yes.
in the sum of circles or in the
same circle. In the same circle. In the same circle.
in the same circle
Yes.
or in congruent circle, two chords are congruent if and only if they are equidistant from the center. FG congruent to GH if and only if LX equal LY.
Ly. So in two congruent circles or in the same circle, two chords are said to be congruent if they are equidistant. If they are equidistant. We will go, thanks Salman, we will go to this example. we will go to this example with نايف الحربي. نايف.
Yes, Mr.
Okay, I need to solve this example.
He said in circle P, EF equals GH equals 24.
Yes.
Find PQ. Okay, first of all, he said EF is equal to GH. EF, so
So
yes, and they equal 24. And the radius is
pay attention. We have here EF is equal to GH. EF
yes,
is equal to GH. So the two chords are equal. The two chords are equal, or they are congruent, and each one of them equal 24. Each one of
yes,
them
24.
equal 24. Okay?
And,
They are equal if they are equidistant. It means this part will equal to this part, which is BQ must equal to B what?
what?
BQ must be equal to B.
PR.
Yes. So these two chords are equal if they are equidistant. Equidistant, it means BQ must equal B2Q.
Mr. Wait, the 4x minus 3 is for what? For EQ?
For BQ.
Okay. And 2x plus 3 is for PR.
For BR, yes.
Okay. I think, Mr. If it's first we can get the radius of EQ and GR.
No
RH.
need for the radius. No need for the radius. Let's go with me by steps. We have here, since the two chords EF and GH are congruent, so they are equidistant. It means BQ equal BR, as we said in the theorem, okay, with Salman. Then after that, BQ equal BR, so 4x minus
Yes,
3 equal 2x plus
X
3.
will be equal 3.
X will be equal 3. Okay,
Yes.
let's go. Excellent. X will be equal to 3. We find the value of X. But we need the value of BQ. BQ equal what? 4x minus 3. Substitute. So 4 times
It will
3
be 9.
minus 3
4 times.
equals to 9. Okay.
9.
So
The
this
same goes for PR.
Yes,
right?
yes. It's equal 9 directly
Yes.
without substituting. Okay, it's equal to 9 because they are equal. Okay, we're going to the last example. So BQ equals to 9. Okay, we're going to the last example with Abdullah. Muhammad Gurney. It's the first time for you, I think, or the second time, Muhammad Gurney. Please, can you solve this example?
Okay.
Okay. In the circle R,
Algebra.
MN equal BO equal 29. Find RS.
And then find ours. Mister, we have to solve 3x and now minus 6 equal x plus 8.
Excellent. So 3x minus 6 equal x plus 8. What shall I do after that?
Minus 6 minus 6.
No. You have a variable in each side, so remove one of them. Which is smaller, 3x or x?
X.
So minus x here and minus x from the other side. Cancel.
I say minus 6 minus 6.
You said minus 6 minus 6.
Okay.
Okay.
Yeah, x. Okay,
So,
6.
okay, there is no problem. 3x minus x equal?
X, 2x.
2x minus 6 equal
minus
what?
8.
Equal 8. Okay, after that,
Then wait.
I need only the value of x. So I need to get rid of negative 6
Yeah,
and 2.
Okay, negative 6 plus 6 plus 6.
So we have to add 6 to both sides. So add here 6 and add here 6 and then cancel. So 2x equal
2x equal
8 plus 6 equal
6
what?
plus will equal 14.
Was equal to 14. So the value of x will be
It will be 14 divided
by 2
no
equal
divided by 2 equal 7.
equal 7. So this is our answer.
No, we find RS.
Excellent. So you have 7 here. So some students, after making
7
all
7
these
plus
steps,
8 7 plus 8 we will find RS. 7 plus
so
8
7 plus 8 because we need RS. So 7
it
plus
will
8
equal
because
15.
RS equal x plus 8. So x equal 7. 7 plus 8 equal 15, as you said. Excellent, Muhammad. So it's equal to 15. Pay attention about this remark. Some students, when they get 7, they will choose 7. And we have 7 as one of the available choice. So please pay attention about the requirement. The requirement is the value of RS, so you need to find RS. Okay. We have an electronic homework for this lesson. Please try to finish your electronic homework. Only about half of the class finish the homework every day or less than. Please, I need your react. I need your participation. Okay. Thanks, my dear students. I have 20 students. It becomes 18 sometimes, but I'll take the attendance quickly by getting a photo for the attendance.